Everyone, I am Ridwan Ibrahim and I welcome you to my YouTube channel. In this tutorial, I would like to show you how you can correct your slab in printer structure when it fails the deflection check. And I will definitely provide a solution as thoroughly as possible. But before we kickstart, kindly give this video a like, and if you haven't subscribed yet, kindly give my channel a subscription because that is really necessary for me. So if that is done, then we can begin. Now we will begin by creating a strip for all the slab, because in printer structure it is the strip that you will use to analyze and design your slab. Alright, so we have three types of strip. I'll be picking the analytical strip, there is FE strip, and there is manual strip. Okay, so in this case I'll be using analytical strip, and then for the X direction I will start from this one at the top here, and then I can hold my control so that I can have a straight strip. Then I'll just left click. Now you can see what I have. It says deflection check L/D equals to 56.18. This 56.18 is the actual span depth ratio of this panel, which is panel 1S1. Okay, and you can see that that is greater than 52.0, which is the limiting span depth ratio. So the actual should not be greater than the limiting, and we are having a problem with deflection here. You can see section insufficient for this particular panel or this particular slab 1S1. So I click on OK. You can see for 1S2, which is this second panel, I'm having the same problem. You can see this is popping up because we have a single strip running over 3 panels. Okay, so I'll click on OK, and then I have the same issue for the third panel. So click on OK, and that's all. So I'm having a deflection problem with 3 panels over there. Okay, we can stop it for now. Then I can go to Y, and then let me run 1 from this side, and then let me drop it over here. So I'm having the same issue, but this time around it is even greater. You can see this is 65.36. okay, so click on OK, click on OK, click on OK. All right, and then you can close this. You can always monitor the value of your limiting span depth ratio, the actual span depth ratio, the depth of your slab, and then many more. Okay, so to do that, all you just need to do is so I'll click on this strip, and then I can go to slab strip design. Okay, then you can see it here. I have 56.18. that is the actual span depth ratio. 56.18, also this other one 56.18, and this last panel 56.18. okay, now this is the solution we are going to provide. Now usually when your slab or your beam or any flexural member is having a problem with deflection, the most common and the most significant solution is to increase the thickness. However, increasing the thickness is not only the solution you can provide. Specifically, the slab thickness here is 120. You can see the thickness here is 120. Okay, so let's say I do not really want to increase this beyond 125, or let's say 130. Okay, what if I increase it to the maximum thickness I want to use, and at the end of the day I'm still having a problem with the deflection? Is there any other thing I can do? Of course there are other things you can do, so I'll be providing you 2 solutions here. One is you can increase the thickness, and the other one is you can reduce the spacing of your reinforcement. Okay, so you can actually provide the two. So you take a little bit of this, a little bit of that, and then you add it together to get a solution, so that you don't necessarily have to increase the thickness of your slab too much. Now if you check this, you see the spacing I have here is 275. okay, let's see for the span reinforcement as well. I have 275. What about the support reinforcement here? I have 275. The span 275, the support here 275, and then the span here I have 275. So I have 275 spacing for all of these reinforcements, both the span and the support reinforcement in this first 4 strip. So now if you reduce the spacing from 275 to, let's say, 150 or 175, by reducing that, you will definitely be increasing the area of your steel. Okay, so when you check the steel table, for example, you can see the spacing here. Let's see for 12 mm. You will see that for 12 mm rebar and a spacing of 75, it corresponds to 1510 mm squared area of steel provided. Okay, now when you increase the spacing from 75 to 100, you will see that there is a decrease in your area of steel. Okay, when you increase to 125, there will be a decrease in your area of steel from 1130 to 905. Okay, so that tells you that the moment you are increasing your spacing, you are reducing your area of steel. Okay, and then when you are reducing your spacing, that means you are increasing your area of steel. So now we can reduce our spacing so that we can have an increase in our area of steel. For example, in this particular slab, I am using Y12 at a distance of 275. You can see my area of steel is 411 mm squared. Okay, so now if I reduce the spacing from 275 and I increase to, let's say, 150, you can see what my area of steel will be. It will be 754. So I have increased from 414 to 754 if I reduce the spacing. Okay, but how does increasing your area of steel exactly influences your deflection? So let me just show you this. Now you can see when you want to check your deflection check, the first thing you need to do is calculate your service stress, and this is the formula for calculating your service stress. Okay, now you can see your area of steel provided here at the denominator, and then you can see your service stress, which is Fs. Now you can see the relationship is inverse, which tells you that the higher your area of steel provided, the smaller your service stress. Okay, so when you achieve a small value of your service stress, that is good, because when you have a small value of your service stress, it will lead to high value of modification factor. Your modification factor may be very close to 2.0, or it may even land up to 2.0 when you have a small value of service stress. Okay, because you'll be subtracting that service stress from 477, which is a constant. Okay, now when you have a high value of your modification factor, you'll be multiplying that with your basic span depth ratio, and that is what will be your limiting span depth ratio. Okay, so now if you have a high value of modification factor, that means you have a high chance of having a high value for your limiting span depth ratio. So when your limiting span depth ratio is high, then you have high chances that your actual span depth ratio will not meet up with your limiting span depth ratio. I think that is clear. So this is how reducing your spacing will influence your deflection. However, reducing the spacing of the rebar will not significantly influence the deflection of the slab in such a way that increasing the thickness of the slab will influence it. And that is why I am providing the two solutions in this video. Alright, so now we can go back to Praether structures. Now I have 275 mm spacing. I am going to reduce this from 275. I will reduce it to 150 mm spacing. Alright, so to do that, you can just go to building setout, and then you go to settings, then you can come to setting center. Okay, you can actually do it in a different way. For example, you can go to analysis, and then you go to building analysis, and then from here you can go to setting center. All that just matter is you should be in setting center. Now I can come to slab because I'm interested in slab. Now you go to rebars. Now under the bar spacing, you can see you have the minimum and you have the maximum. The maximum here is 300. Now I'm going to reduce from 300. I'll just put it in 150. Okay, so 150 will now be the maximum spacing for my reinforcement of the slab. So click on OK and then just close this. Now this will not change at the moment. All you just need to do is you right click and then you can click on update steel bars. Okay, so click on OK. Now when you do that, you will realize that this has changed from 275 to 150. Alright, so now when you now check back your reinforcement, you might realize there is a change and there might not be a change, just as I've mentioned earlier, that it will not significantly affect it, because this is a software. It works with approximation, it works in a constraint. Okay, but of course if it is a manual design, there will be a difference in the calculation, and because you are the one who is designing it, you can actually manipulate it the way you want. But this is a software, it will work with approximation and constraint. Okay, so let's see the this particular one. Let me click on this strip and then I can go to slab strip design. Originally it was 56.18 and right now it is still 56.18, so this did not change at all. Okay, so click on OK, and now if I click on this, I know this was 63 point something, so go to slab strip. Now you see this has changed from 63, it was 63 point something earlier, now it has changed from 63 to 56.18. okay, at times if this did not change, you might have to reanalyze your slab. You go ahead to reanalyze your slab and then you update your steel bar reinforcement one more time. You just go to build the analysis, you rerun your analysis, and then you will update your steel bar. Maybe this will change. So if it does not change, that means it is not changing at all, but it might as well change. As you can see, this has changed from 63 point something to 56.18. Now you can see that at least you've reduced it. It is still a failure because your actual span depth ratio is still greater than your limiting span depth ratio. However, it has reduced it from 63 to 56. Okay, so just click on OK, and now the next solution will be to increase the thickness. So you can see we are taking little of that and then little of this, so we not have an exaggeration in increasing our thickness. And just as I've said, increasing the thickness is the major correction you can make to your flexural member when they have a deflection problem. Okay, so to do that, just right click on the empty space like this, just right click, and then you can go to member table. Now I will go to slab table. I will increase my thickness from 120. I will increase it to this will affect my analysis. There's no problem, just click on yes. So I will change this from 120 and then I can change it to 130. Okay, so click on, you can see I've just added 10 mm. All right, and then you can close this, and now you can rerun your analysis. I'll be quick about this. Design is always a try and error something. It is not just a one-way thing. You have to modify before you get a solution that you are comfortable with. So click on OK. So now I believe we should have a good value. Now I'll just click on this strip and then go to slab strip design. So now you can see that my limiting span depth ratio is now greater than my actual span depth ratio with a value of 2. Okay, it has no unit, it is unitless, so it has a higher value. So that is perfect. Just click on OK. Let me check for this other one in the y-axis. So click on slab strip design, and then I think that is the same. So this is doing fine. You can click on OK. Now at the end of the day, we've corrected the deflection problem of this slab. So this is how you go about correcting your slab when it fails the deflection check. If you like this video, kindly give it a like, and if you haven't subscribed to my channel yet, kindly give it a subscription, because you'll be enjoying more of explicit civil engineering and structural engineering content on my channel. Thanks for watching, and thanks for always coming.